and Dan, who are racing from point A to point B, and then like we discussed earlier, the transportation mechanism is not relevant. So we created an interface that has just called transporter, and it has just one method which we declared, which is called move. And now there are two transportation mechanisms, car and bike, and they have both implemented this interface, and they provided the definition for the move. And the way to implement this is to use this keyword called implements, which actually yes implements. So, so that is about interface. Um, okay, so here we are providing the definition. So we have two means of transportation, the car and the bike, and both of them are implementing this transporter interface. Right? So now, like we discussed earlier, we need to use this override annotation and provide the definition for the class, definition for the method that was declared in the interface. So which in this case is move. So the way the vehicle moves is now up to the class to define. So at the interface level, we are not bothered on the mechanisms of it, right? So we are not bothered on how the movement happens. But once the class implements the interface and provides definition, it should know how the movement should happen. So in this case, it will drive, and in the case of bike, we will have to pedal. So that's the transportation. So now we'll use, so in the racer part, in the racer class, again, we are not bothered about the transportation mechanism, right? So the only thing that needs to be taken care of is that it should move from point A to point B. So that is all we are bothered at the racer level. So we can use something like a transportation here, use transportation, which can be more general compared to what we have discussed in the car and the bike. So we'll use something like the transportation, and there can be multiple modes of transportation. Like there can be a car, bike, a hoverboard, horse, or whatever. Right? It can be multiple modes of transportation, um, and we can go from point A to point B. Right? Okay. So now let's look at this polymorphism. So it consists of two words. The first one is poly, and the other one is morph. Right? So poly meaning many, and morph means form. So polymorphism would be many forms. So many forms that it can take. Right? Um, so in the case of the previous example, so here you have many forms of transportation. So you have a car, bike, and motorcycle, horse, etc. So these are the many forms of transportation, but racer is not bothered about it. So racer is only bothered about the end goal, which is going from point A to point B. And whoever calls racer, so that means whoever is racing in that particular event, can choose to decide among whatever means of transportation is available. Right? So there is some sort of abstraction here, abstracting away from the details, the implementation issues. So, but we'll look at it in more detail in this next set of slides, right? Um, so the thing that is common across all these transportation mechanisms is that they move. They move from one place to the other. So there are a couple of other examples. So if you look at phones and camera, the thing that is similar to both of them is we would need to charge them. So both are chargeable objects. Right? So the way to charge them could be different. Say, for example, in or the way to charge or the duration of the charge, they all of them could be different, right? But at a high level, both are chargeable. And the other example is between cars and mobile phones. So one of the similarities is that they both can play the radio. So if you can create an interface called, radio player, And now car and the mobile phone can both implement this radio player using the play radio method, right? So again, the way to play the radio is slightly different, and each class can provide its definition for it. Okay? Okay, so now let's get back to the use transportation method here, which is part of the racer class. So here, if you go back, so if we are not making use of this general use transportation, we would have to do something like this, right? We'll have to say use car, use bike, use horse. So all these are different. So if there are 10 different mechanisms of going from place A to place B, you would have, and you would end up with 10 different methods. So instead of that, can we make use of only one method, which is general enough, and then leave it up to the caller to figure out which mechanism to use. So that's an advantage here. It will reduce the amount of code, right? And it's also easily extendable. So let's say you have implemented 10 different methods, which are given here, and after let's say 2 months, you're given a new requirement that there's a new means of transportation that needs to be added, which is a bus. So since bus is not here, you end up adding a 11th method called use bus, right? And later on in the future, after say 5 more months, they want to add one more transportation mechanism, which is train. So you end up adding one more, right? So there will be 12 methods. So instead of that, we are restricting this to only one method, which can do the job of all these methods. So we'll see how that happens, right? And that is the advantage of using this interface. Okay. Uh, so use transportation method will now take one argument, which is the transporter. This is the interface. So this is the type followed by the type name. Sorry, the variable name, which is transportation. So here you are simply saying transportation.move because that's the only method that is part of the interface. So you can only use just one method. But when we call this use transportation method, we can pass in various types of arguments, which we will see in the next couple of slides. But this is what is referred to as polymorphism, right? So you have this transporter object can now take multiple different forms. It can take the form of a car object or a bike object or a horse object or a train object. So although we are referring it to it by one name, internally it can take multiple different forms. Right? So that's it. That is why it's called this polymorphism here.
Excuse me, sir.
Yes.
So we are just generalizing all the common properties.
Yes, we are generalizing. That's right. We are generalizing the common properties, which here is move. So both car and bike have one common characteristic, which is move, and we are generalizing it and then pushing it to the interface. Yes.
Okay, sir.
Okay. So now, so there are two types here. So in order to understand this, we would need to know more about these two types. One is the actual type, and the other one is the declared type. So we'll just make the distinction in the next couple of slides. Right? And this is the second issue that we need to look at, which is the method resolution. We'll again look at this in the next few slides. So we'll start with this actual versus declared. So, so in this one, you have the transporter interface, the interface transporter. So this is the type here on the left hand side. On the right hand side, you are saying that the type should be car. Right? So the first question that could come up is this even legal in the sense in terms of the Java syntax, right? So is this even legal? Because so far we have seen that let's say if there is a string on the left hand side, then you end up creating a string object. So you can only assign string object to the string type. So both the types on the left hand side and right hand side should be the same. Or if you have, let's say, car on the left hand side, you should have car object on the right hand side. But here it's slightly different. You have the interface on the left hand side and the instance of car on the right hand side. So, um, so the first question could be whether it's legal, and the answer is yes, it is legal, because car is implementing the interface called transporter. But there's a catch here which we'll get to know next. So we can treat these car and bike objects as transporter objects. So car is the actual type, transporter, which is the interface, is the declared type. So the catch here is that this is the one. So using this particular instance, so in this case, let's say transportation, you can only call those methods that are part of the interface. So let's say the transporter interface has two methods, which is move and play radio. So then you can only call those two methods, even though car might have more methods. So let's say car has 5 methods, and among those 5, 2 are from transporter. So it provided definition for the 2 methods of transporter. So apart from those two, it can also it cannot call any other method. So for example, car has brake, right? But transporter cannot, using the transportation object, we cannot call brake on it. We can only call play radio and move. So that's the limit or the restriction here. But the advantage
Excuse.
is now that you can use this type to call on to associate it with any object that the interface implements.
Sorry to disturb, sir.
Yeah, yeah, no problem.
Sir, I have a doubt regarding that. Are we only allowed to access the default constructor of the car, or can we access our own implemented constructor of the car also through transporter
No,
interface?
yeah, yeah, you can. There's no restriction on the type of constructor that can be called here. You can call any constructor, so that can have arguments, or it can have the default constructor. Um, as long as the object or the instance of that particular type is created, it is okay.
And if bit within, like, let's say transportation dot move moves the car, and now let's say let's assume that play radio was not a part of the was not a part of transportation. It was a method that was limited to the
Hmm.
class car itself. So I can call in that function. I still can call
Yes,
play
yes.
radio, right?
Yeah, yeah, you can do that. You can call within that, but you cannot call directly on the transporter object. And the reason is that it does not know, right? So a transporter object knows only about the methods that are part of transporter, which is move and play radio. So what you're saying is you are, by assigning this instance, you are saying that okay, I'm providing the definition for those two methods, so you can use this definition. But transporter does not know beyond these two methods, anything else other than these two methods. So it cannot call other methods. But like you said, internally inside this method, you can call any other method of car also.
Thank you, sir.
Sir, is
So
it
I had one doubt.
Yeah, okay.
Okay, you can, you can.
Sir, is it like we are inheriting just like if we declare two classes, just like we take example a transporter class and a car class. Is it like we are inheriting transport class so that the car class can use the functions of transporter, but transporter cannot use the function of car. Is it like that?
Uh, yeah, so in some sense, yes. So it is a way to do the inheritance. So that's why I said we'll also talk about this when we look at, say, multiple inheritance. Because in Java, you cannot do multiple inheritance, and interfaces provide a mechanism to do the multiple inheritance, right? But yeah, but we'll discuss that during that topic. But yeah, you are right. In terms of the way it works, the way you specified is right. So transporter can only have access to the methods that are declared in that interface because it doesn't have the visibility for other methods. The only thing that this assignment does is it provides it provides the definition for those two methods. So now you are saying that okay, now use the definition of the move or the play radio methods provided by the car. And if it is new bike, then you are saying that okay, now use the definition of move and play radio that are provided by the bike. So that's it. Are there other questions?
Yes, I had a doubt.
Yeah.
So just like you said, we know now that a single class can implement two different interfaces, right?
A single class can, yeah.
But then we can only create like we can only have one declared type for an object, right? For example, here we have transporter type transportation, and suppose our car class was implementing transporter as well as colorable.
Hmm.
So what is the use of implementing two different interfaces when we can only use one?
So in the one interface itself, you want to add all the methods, is it?
Could you repeat?
So instead, say you want to add the colorable methods also inside transportation. Is that what you're saying?
Yeah, yes.
Okay. Um, okay, yeah, you can have only one interface. So it's very similar to having just one class in your entire application. Right? So the other important point that we discussed earlier is division of responsibility. So okay, this one is very similar to class, right? In some sense, so uh, the responsibility of each interface should be uh, cohesive and concise. So in the sense that you cannot have unrelated methods as part of one interface. So transportation has nothing to do with the color, right? So you're only focusing on the transportation mechanism. So in the color, if you we are only looking at the things that are related to the color. So it doesn't have to do anything with transportation. So that's why they need to be separate.
But sir, if the car implements both transportation and colorable interfaces, so
Hmm.
can I write transportation dot move and transportation dot set color?
No, you can't do that. So transporter knows only about uh, the methods that are declared within this interface. So you cannot say transportation dot get color, but you can say colorable. Okay, let's use colorable color for example, and then new car. Then you can call set color and get color on this instance, but you cannot call move on this one.
Although the car implements both, but because transportation is of transporter type, it will only implement the methods in transporter.
It will only uh, it has visibility for only those methods.
Okay.
It cannot see beyond those two methods. Or it
Thank you.
doesn't know, not in the sense it's not see actually, but it doesn't know beyond those two methods. Right? It only knows about those two methods.
Okay, sir,
Excuse me.
got it.
Sorry to bother. Excuse me, sir.
Yeah.
I have created an object car, which is my method of transportation. Now, what if I need to set the color for this object of this method of transportation itself? So how would I do that? Like I have to do it for the same object. I do not have to create another object. If I have to set color for the very same object, transportation, how would I do that?
So you cannot. So if the type is transporter, then you cannot do that. So this only deals with the transportation part. So you would have to say car. So replace this transporter with car type. Now car type can have access to all the methods defined within the car, so including that of transporter and colorable. So that's the only way you can do
And sir, this might be a bit off topic, but are interfaces allowed to only implement, are interfaces, sorry, can interfaces only contain abstract methods? it cannot contain any predefined methods.
That's a good question. From what I remember, it cannot, but yeah, I'll have to check. I don't know. I'll have to. I can check it and then post it on the classroom if that's okay. But from what I remember, at least in terms of the purpose, right? It's not meant for methods that have the body. So it's meant for like these the purpose that we have seen. Like it's to provide the contract and let the implementing classes take care of the definitions. So, but yeah, I can check it and then I can post it on the classroom. I can get back to you. Is
Thank you
that
so
okay?
much.
Yeah.
Yeah, thank you, sir.
Yeah, thanks. Okay, so shall we move on?
Hello, sir.
Yes.
Sir, I have a doubt. If we use car instead of transporter to create an instance of car, then we can use this instance for maybe you in use transportation method.
Mm-hmm. Yeah, yeah. So we'll be coming to that. So yes, that's right. So if we create a instance of car, yeah, we can use it. You can pass that to the use transportation method, and that is what we'll be getting to, right? So this is the introduction to that one, so to say. So are there any more questions? Okay, so let's
Sir,
yeah.
I have a doubt. Suppose a class is implementing two interfaces and they both have methods which have the same name but different arguments. So, will the class be able to override the methods?
Yeah, yeah. So if the methods are different, yes, then
No, they have the same names, but the
arguments are
arguments are
different, right?
different.
Yeah,
Yeah.
yeah. So the signature is different. So as long as the signature is different, it uh, doesn't create any conflict. But
Okay.
if two interfaces have the same signature, then that's an issue, and that it'll result in error because there's some confusion, right? Now the class does not know um, which method of the interface it should provide definition for. So there will be an issue there at that time. But if the signatures are different, then that's not an issue. Okay. So here we have seen that there are two classes, bike and car, that are implementing this transporter, right? Um, so again, we have discussed the reasons. So this is trying to generalize it, and then trying to look at the similarity. So similarity is move. So it's trying to put the similarity in the in the interface, and then it will let the implementation aspects be delegated to the classes. Okay, so now the one way of looking at this interface is in terms of this implementation, right? It's that it's a lowest common denominator, meaning that the thing that both these classes should definitely implement, even though let's say it does not have any other method, it's still okay. Right? But the thing that it should definitely implement is this move. So in that sense, it's the lowest, least thing that both the classes should do. And the thing, and we say there's a common element because both of them are implementing the interface. So that's why there is a common element, which is the implementation of move, and it's the lowest possible one because uh, it's the only, even if it's the only definition that the class provides, it's still okay. It can have more methods, so that's why it is the lowest form, lowest common denominator. So it's that so interface implementation is like the lowest common denominator, and that's why since it is the lowest common denominator, we can use the interface as the type to refer to the instance of the class. So this is the other way of looking at this particular statement. statement where we use the interface name to refer to the instance of the car, right? Because this is the lowest common denominator. Right? So these again this question. So we have anyway seen the first one. So you have an instance of the interface. So transporter, the variable name is Sophia's bike, and now you said new bike. So you are assigning an instance of bike to this particular variable. So this one is again legal because bike implements transporter. So what about this one, the second statement? So is this legal in terms
No.
of the Java syntax? So one of one of you can unmute and let me know. So there'll be a series
Yes, sir.
of questions. Okay. So the next one is the radio. So there's a class called radio, but radio is not implementing the transporter interface. So in this case, is this legal?
No.
No, sir.
No.
Yeah. So yeah, this is not legal because it's not um, implementing this interface, right? So now there is no relation between this interface and this class. So earlier, this is the lowest common denominator, as yes. Yeah. So we use this term act as in the previous lecture, right? So radio would now, so car and bike would act as a transporter. So radio cannot do that. So because it hasn't implemented transporter, so we cannot have this assignment here.
Excuse me, sir.
Yeah.
So, like for example, if I have two interfaces, let's say one is transportation and one is acceleration. So I definitely, like, if I need to accelerate, I definitely need to know how I am moving. So like, can an interface implement another interface?
Yeah, I think that is possible. Yes, from what I remember, yes. Yeah, you can implement one interface can provide the it can use implements other interface, but yeah, again the interface that is implementing it
Uh,
cannot provide the definition.
Excuse me, sir. Won't that be a part of inheritance rather than implementation? Because one interference is kind of inheriting another interference.
Okay. So whether we call it the inheritance or not is yeah, that is right. It does in that sense it will inherit the properties of the parent interface. But I think the question is, can we do it or not? I from what I remember, you can do it. But again, I can check and post it right on the classroom. But you should be able to do it.
But in that
So
case,
let me note this down.
yes,
Yeah, you can go on.
yeah, but in that case, like the one which is implementing the other one,
Hmm.
in that we have to define the function. We know that the interface themselves do not have any definition. They just end with a semicolon. How would that work?
Sir, I checked on the net and it said that extends would be used and not implements when we are like using one interface for like referring to another interface.
But if we use extends, then it's no longer an.
So that's
So
because
if
it's
you're using
inheritance,
extends, then
not
you are
implementation.
you should provide the definition, right? Yeah, I don't know if it's so. It doesn't, in that sense, only look at the declarations. So if you are looking at just the declarations, then you cannot use extends. So extends is you use it for inheritance where you are borrowing or getting the characteristics of the parent, whoever is the parent, and then you are free to either extend it or extend the functionality or reuse the existing functionality. Yeah.
So, so, excuse me, so.
Yes.
Actually, on the net, it's saying that an interface cannot implement another interface as because if any interface is implemented, then its methods must be defined, and interface never has
Right.
the definition of any method.
Right.
So the only thing that you said, how is it correct then?
Yeah, so so I was so okay. Like I said, that is what I remember, right? So I don't. That's why I said I'll look it up and then I'll post it on the classroom. So yeah, I made note of these two questions, so which I was not sure about. One is the default method implementation that one of you asked. So can the interface have one of the methods? Can it have some default implementation which can be overridden? So that part again, in theory, it's not good to have that because you're ideally you should leave the implementation to the class, the implementing class. But again, if Java provides a mechanism for it or not is something I'm not sure. So that's why I made a note of it. And the second thing is, again, these also in theory, like I said, interface should not be implementing any of these methods. So in that sense, even though it implements, it should not. It can again have only the dummy or just the declarations, right, without any body. But again, like I said, this is something I'm not sure of. So I'll look it up and then I can post it. So I made a note of these two questions. Yeah, but yeah, you can. Yeah, I guess one of you looked it up, right? So yeah, I don't know. Let me also check it, and then I can get back to you. But if there are any other questions, do let me know. Okay, so let's go ahead. Uh, So let's come back to the polymorphism, right? Or how interfaces can be used for implementing the polymorphism part. Polymorphism, as we have seen earlier, it has two words. One is the poly, which is many, and morph is the form. So it takes multiple different forms. So in this case, we'll be using the transporter interface to demonstrate these multiple forms, right? So here, there are two aspects. One is the general part and the specific part. So in the interface, we generally deal with the general part of it. So we look at the common aspects and we generalize it. So generalizing is nothing but here we are ignoring the implementation level details, right? So the implementation of the move method, for example, is delegated to the particular individual classes, and we are only saying that we are bothered about whether something moves or not. So that's what is the general part. Now there can be multiple different implementations, and that is where the polymorphism comes in. So we'll just look at that in the next few slides. Okay, so I'll skip this. I mean, we already covered this part, right? Um, yeah, like I said, so razor, this razor class, it only wants to move from one place to the other. It doesn't care about how the movement happens, whether it's through a bike or a car or a train or something. So in that sense, we are only worried about, or we are only looking at it from the general uh, point of view and not the specific details of it. Um, so in the racer class, we can make use of this use transportation, and it will take in this declared type. So this is the declared type. So a few slides back, we looked at two types. Right? One is the actual type, and the other one is the declared type. So if we use the declared type here, which is nothing but the interface. Now this interface argument, it can accept any instance that implements this in particular interface. So let's say car and bike, if they implement this interface, then the instance of car and bike can be passed. But if it does not implement, let's say radio, then it cannot pass in those that as the argument. Right? And this is the other restriction that we looked at, which is this transportation object can only see or call those methods that are part of the declaration of transporter interface.
Excuse me, sir.
Yes.
Can you go back to the previous slide?
Can I go back to this one?
So this is saying that the use transportation method can only call the methods declared in transporter. So why is that? Because use transportation is a method in the racer, right? And racer does not implement the transporter interface. So why is this limitation?
Yeah, that's right. Yeah, this is wrong. So this should have been transportation. So this instance.
Yeah, so the transportation object basically can only call methods which are in the transporter interface, right?
Yeah, right.
Okay.
Yes, so this should have been transportation and not use transportation. Yeah, that's a good catch. Okay, so maybe I can just right. So this should have been something like this. Right. So transportation is what it should have been here. Okay. So so first part is the assignment part. So we have already looked at it. So you can assign any instance of a class that has implemented the transporter interface, and then you can use that interface to only call those methods that are part of. Okay, so you are simply passing it in. Okay, so we haven't yet got to that stage. So now you can pass in the instance of Sophia's bike, because bike class has implemented the interface called transporter, and the same is the case here. So you can use car, you can create an instance of car and pass that as the argument for use transportation, because car has implemented transporter. So this is okay, and then the third one is so you have created an instance of a radio called Sophia's radio, and then you are passing that as the argument for this use transportation. So use transportation only takes in instance of type transporter, right? So now this class has not implemented the transporter, so this is not legal, right? Legal in the sense it doesn't stick to the syntax of Java. So this one gives an error because, like I said, it didn't implement transport.
Sir, excuse me, sir. I have a
Yes.
doubt. Sorry. Underscores. What is underscore Sophie?
So that's a okay. So if you
That's
go
a
back
racer
here,
class object types.
yeah. So it's a that's right. Where was that class? Oh, I need to go back quite a bit. So yeah, racer. Where did we declare racer? Yeah, this is the one. So racer has one method which is use transportation. So underscore Sophia underscore Dan or whatever. So they are all instance of the racer class.
Okay, sir. Thank you, sir.
Sir?
Yes.
Sir, in that example, when we used car, Sophia's car equal to new car, and then passed it into the method, so does it get typecasted into the transporter type?
Oh, we have already seen. Oh, just let me just go back to the slide that I was on. Yeah. So your question is whether, sorry, bike instance gets typecast to transporter.
No, sir. The car one. Car, Sophia's car equal to new car, but then we passed it in the method which was expecting a transporter type.
Mm-hmm.
So does the type get changed? Because car, Sophia's car is a different thing. It can access the methods of car as well, right?
Yes, it can access the methods of the car. That's right.
So when we call it in the original method in the use transportation, it will be passed as a transporter type, right?
Yes, it will be passed as transporter. That's right, because you are making that assignment. So you are assigning Sophia's car, which is an instance of car, to transporter in the use transportation. So it can now, within use transportation, it can only look at the methods declared within the transporter interface. But here, in the next sentence, you can use any of the methods of the car. So yeah, in that sense, you're right. So it will, once you call this, it will get typecasted to the transporter interface type. But
No,
I think
sir.
we'll look at this typecasting at a in the later class, in one of the later classes. I think.
Excuse me.
Yes.
Sir, in the second line, underscore Sophia dot use transportation Sophia's car. In this use transportation method, the object Sophia's car can only access the methods which are declared in the interface transporter, right?
Um, yes, if it is within use transportation, yes. So it can only access the methods declared within the interface transporter.
Yeah, because it gets converted into that transporter object.
That's right. Yeah.
Okay, thank you.
So, sir, even after we use Sophia dot use transportation, Sophia's car, we can still in the next line or in the next to next line we can
Mm-hmm.
call the car methods also, right?
Yes, yes. So here, once you are outside of the use transportation, right, you can, for example, in the next line here, you can call any of the methods of the car on Sophia's car.
Okay, sir. Thank you.
So
Excuse me,
shall,
sir.
yes.
So like here we are converting like with parameter passing, we are converting a car object into a transporter object because car contains some of the methods of transporter.
Hmm.
But can it happen other way around? Like if I transporter Sophia's bike is equal to new bike, and let's say I declare another method in which a bike object is supposed to be passed. Can it be like supercasted in the sense like the transporter, the parameter that is being passed can access bike methods also?
Okay, I didn't get this. So, so you are now passing the instance of bike to use transportation, is it?
Yes, sir.
Okay, then it will behave in the same way, right? So if you pass the interface of, sorry, instance of bike, within use transportation, it can only access move. It cannot access anything else.
So I'm asking it. What I'm asking is, like here, an object of car is being passed as a transporter object
Okay, yeah,
in our
within use
example. But
transportation, yes.
yeah, within use transportation. But let's say if use transportation were to accept a car object, and let's say it was I declared like
Oh,
in this part of the code, I declared it as transporter Sophia's car is equal to new car.
and you
And
want to pass bike now,
no,
bike instance.
if I'm passing car instance now, if I'm passing car instance now, but it was declared as a transporter here. So if it was declared as a transporter here, but in the function call, it's declared as a car. So then in the inside the function, can I access car methods?
I'm not. Okay, so okay, let me try and understand. So you are saying that so let's say the instance. So you have transporter Sophia's bike, and you are assigning instance of bike to Sophia's bike, and here you have the car. Is it? So use transportation has car Sophia's car, and now you are passing in this to this particular one. Is this what you're saying?
Where
So
what
you
I'm
pass
saying
in.
is in use transportation, the parameter we decided, the parameter we wrote was transporter transportation.
Yes.
So here, if any object that has implemented transporter can be passed as a transporter object.
Yeah, yeah. So that's right. So
So, but can it happen the other way around?
what
Like
is the other one?
for every class that has been implemented transporter, if I pass a transporter object, can I can I cast it into another like can I cast a transporter into car? In the sense like here in this example, transporters, Sophia's bike is equal to new bike.
Hmm.
And let's suppose my transporter use transportation function was accepting a bike argument, bike parameter.
Okay.
So can it, inside that function, can it access bike methods also then?
Inside this, yes, it should be able to. So let's say again, use transportation, you can access bike, but once you, that's the reverse case, right? So if you come out of the use transportation somewhere here, right, then you can only access the methods of the transporter. So inside use transportation, it will act as a bike instance, but outside of the use transportation, it will act as the instance that only knows about the transporter methods.
Okay, thank you.
So I did not understand what you explained right now.
So here, so let's say we have this particular statement at the top, and for use transportation, let's say the type that use transportation takes is bike followed by some parameter, right, and not transporter.
Okay, sir.
So in that case, the question was within use transportation, can we use other methods of bike as well?
Okay, so can we, sir?
Yeah, so within use transportation, it will now act as a bike object. And outside of the use transportation, it will act as the object that knows only about the transporter methods.
Okay.
Sir, but if the use transportation accepts a bike object and you pass Sophia's bike in this case, so inherited in Sophia's bike is actually a transporter, right? So it anyway can't, so if you typecast it into a bike, it can't actually access the methods of the bike class because it is actually a transporter.
Yeah, sir,
Even
same
if you
thing.
even if you
So-
typecast it, so this is basically small bucket to big bucket wala question.
So it has been, so internally or not by its nature, it's a byte, right? But you have just typecasted it so to the transporter. Typecast in the sense, okay, so you are restricting the scope of the access. But when you pass in as the argument here again, that
So
no longer holds, right? Like you are
yeah,
again.
so if I so Sophia's bike actually was earlier a transporter. Now I typecast into a bike. So but earlier it was only able to access the methods of the transporter interface.
Right.
So, but now if you typecast it, how is it possible? Because how is it possible that now it can access the methods of bike class?
Okay, by its nature, okay, so by its nature, it's a bike, right? So it's an instance of bike. So although you are typecasting it, it's not okay. I don't want to use. Okay, so you are saying that uh, with the Sophia with this particular instance of transporter, you are referring to this bike instance. So since you are doing that, this particular one can only have access to, or it can have the visibility only to the methods of this particular declared within this interface, right? But now you are passing in the same reference to a regular bike instance. So in that case, originally it was anyway a bike instance, and now you are passing it to this one. So it should be able to look at it, right? At least so only within this use transportation, it should be able to look at it. Okay, outside of it, again, it turns back to the regular transporter. That's what I.
Sophia's bike can the objects by
Your voice is breaking.
so the Sophia
No, your voice is still not
of
clear.
the bike class. Hello. Hello. Am I audible?
Yeah.
Yeah. So the Sophia's bike can also access the method of the bike class as well then?
Okay,
I'll just
your voice was still not clear, so I didn't get the question.
Sir, I was able to hear it. Correct me if I'm wrong. He was asking that can the Sophia's bike object can also now access bike methods? I think so. That was his question.
yeah, that's
So
the
in this
question.
case, so Sophia's bike, if it's a transporter, it cannot do so, right?
So, okay. So how Sophia's bike is being able to pass as an argument in a case where use transportation takes a bike type object. Yeah. Just
So I already mentioned that, right? Okay, um, so if you, so originally it was a bike instance, and now you are assigning it to a transporter type, right? So now, as you have mentioned, it cannot have the visibility beyond that, but it was originally anyway a bike instance, right? So when you go here, uh, it goes back to a bike instance again. So that is what I think.
But,
So if there is
sorry.
sort of confusion, yeah, okay, let me do that. Right? Let me also, yeah, you can go on
So
with your question.
basically, we
Why
can
don't I
say
move?
that inside the used transportation method, it becomes a separate bike object, right? That is only in the
It's
scope
not a
of that
separate.
methods. I mean, for the scope wise.
Yeah, within the scope. Yeah, that's it. That's what I was referring to. Right? So within the used transportation, it is still a bike instance.
But sir, if Sophie bike has only access to only the interface functions, so so how can it implement other bike functions? Even if it is natively a bike instance, it only has access to interface functions, right?
Right. So that was outside of the used transportation. So okay. So let me. Uh, why don't I look it up and then post it? So if there is lots of confusion, so I can again check it and post it. For now, let us move on if that's okay, right? Because we are going around the same question again and again, right? So this is what I think it is. But if you don't agree, then I can just confirm, look it up, confirm, and then post it. Does that sound good?
Yes, sir.
Okay. We are almost coming to an end. Okay, so again, so in the racer class, you're using this use transportation, and you have the uh, you're making use of this interface, right? So again, this interface can only access the methods declared within the interface, which is move. So you can only do that. But if you pass in the instance of bike or car, so this move would now get called on that particular object. So it's either the bike's move or the car's move, and they are implemented in different ways. Um, yeah, we already know this, right? So transporter cannot call the instance of transporter now cannot call any other method that it cannot see. So it can only see the move, and that's why it can only call the move. We already know this. Okay, so this is again important, which is method resolution. So you have this particular line here. So you are passing in a bike, and you are calling in with on calling the move. So now this move, the bike's move would get called here because you are now this instance is now referring to the bike's instance. And if you pass in a car's instance, uh, the move method of the car gets called. So that's why um, so the resolution happens at runtime, right? So if you look at it during the compile time, it cannot it will only look at the syntax as such, and it cannot figure it out. But during the compile time, it will know that, okay, the instance of bike has been used here, and that's why the move of bike should be called. And if it's the instance of the car, then the move method of the car would be called. So the actual type here is the bike, and declared type is the transporter, right? So the actual type gets resolved during the runtime here. So a couple of some more examples here. So the way you again use this transportation is you pass in some argument of either the bike or the car. And these are the ones that implemented the interface. So bike is the actual type, and you have the transporter, which is the declared type. So now once you pass in the actual type to the declared type, it will know the method on which object to call at runtime. So if you pass in the bike, the bike's move would get called, and if it is the car's move would get called. And I think it's all. Okay, we have already covered this, right? So the visibility of the transporter, and then what are the methods that can be called on bike, and so on. Yeah, in this example, they are passing in car. So in the previous one, we have looked at the one where the bike's instance get passed. So in this case, the move of the car would be called. So this is what is called as resolution. So we are resolving this at runtime, and that's why it's called dynamic binding, right? So the here the binding refers to the process of. So once you call, you make a method call. You need to resolve to which particular definition it should be bound to. So whether it should be the definition of the car or the bike, right? So that happens at runtime, depending on the type that has been passed. Right? So that's why it's called dynamic binding. So in the other cases where you have a direct call, so it's not, let's say, using the interface. So it already knows the type from runtime, and that's why it is the static binding. Right? So there is a difference between these two types of binding. Okay. So again, this is the advantage of using this interface and polymorphism, right? So for example, now you can have 10 different classes, say car, bike, train, flight, bus, etc. And each of them can define their own move method. And now at runtime, you pass in the instance of which you want to call the move method of, and then that will get resolved at runtime, right? So for example, now you want to race using a bus, so you pass in the bus instance. And if you want to race using a car instance, so you pass in the car instance, and it will get resolved, right? So at the level of the racer, these details are abstracted. So there's one more question here, and so we'll take this question and then I'll stop the lecture. So you have the laptop class, and it implements two interfaces, the typeable and then the clickable. So, and it has two methods which are here. So one is the type. So the type belongs to the typeable, and the click method is from the clickable, right? And it's implementing both these methods. So assume that type interface has only one method, which is type, and clickable interface has only one method, which is click. So given this these declarations, yeah, can you let me know which one is valid among them? So in the first one, you have typeable.
A and D.
Yes. Okay. So you have your so here you are creating an instance of the interface itself, which is not correct, right? So you cannot create an interface. So you cannot create an instance of an interface. So that is where this is wrong. So in the second case also it's the same. So you are creating an interface or instance of the interface, which is not possible. Interfaces cannot have instances. So let us look at C and D. So in the C, you have typeable MacBook, and then you are assigning this instance of a laptop to it. So in this case, you are calling the click method on it, but again, the visibility of typable is only until the methods that are declared within typable, and in this case, it's only type. So this is wrong. And the last one is clickable. You assign new laptop, which is correct, and you are calling click on it, which is again correct. So because clickable interface can only look at the click, and it only has visibility until the click. So it doesn't know about any other methods. So this is okay. So for example, if it's macbook.type, that's wrong. So now the only thing that is valid here is the D, because yeah, as I said, you're creating an instance of an interface which is not